everyone. In this video, I'm going to be going over how to do calculations with the combined gas law. So if you haven't done it already, make sure you have down the formula of the combined gas law. PV over NT equals PV over NT. The combined gas law is used when we're trying to predict what will happen if we change the set of conditions on a gas. So for instance, if we have a gas at a particular pressure and we increase the temperature from 10 degrees to 25 degrees, what will the new pressure be? Those are the types of situations where we would use the combined gas law. So if you take a look at what's in purple on the page here, or actually, that's not what I want you to refer to. Oh, what's in gold. So it says the combined gas law is used when gas is undergoing a change from one set of conditions to another. The reason I'm really pointing this out is because later on in this unit, you're going to be learning the ideal gas law, which only deals with one set of conditions. So this is something that you use if you are going and comparing two sets of conditions. In terms of units, the units can really be whatever I give you, as long as what you have on one side is the same unit as what you have on the other. So if I ask you for a second volume, you can give it, you can put it in the volume of whatever we had to start. Temperatures do have to be in Kelvin. So remember, you have to add 273 to the temperatures given to you, and you only use the portions that apply to the question. And I'll go through a couple examples with you. We'll do green. So if you take a look at the first one here, it says a sample of oxygen gas is at 45 degrees Celsius at 0.88 atmospheres. What pressure will it have at 100 degrees Celsius? So here we are given a temperature, and we see right away, it's in degrees Celsius. I need to change that to Kelvin. So 45 plus 273. And our first temperature is equal to 318 Kelvin. We also have a pressure. It's asking for pressure. And we have our second temperature. And 273 plus 100 is 373. Now, if you take a look, we only have a question that is asking about pressure and temperature. So when we decide what formula we're going to use, we just want the formula that involves pressures and temperatures. So here we have a pressure, here we have a pressure, here we have a temperature, here we have a temperature. So we have P over T equals P over T. And that's the formula that we're going to use. So P divided by, T equals P divided by T. And we're setting up proportions here. So then we can go and plug in our numbers. So we have 0.88 atmospheres divided by 318 temperature equals, it's asking for pressure. If you want to put a P here, you can. If you want to put an X there, you can. And then it's just like math class, solve for X. And then we divide it by the second temperature, which is 373. Now, at this point, you can solve for the missing variable. So we're solving for P. And there's different ways to calculate how you want to go about doing this. You can either cross multiply, or you can multiply the 373 to the other side. Okay, so I'm going to do 0.88 divided by 318 times 373. And it gives us 1.03. So the new pressure is going to be 1.03, and it is pressure, and we started with the atmospheres. So our answer is going to be in atmospheres. Okay. The second problem, and this one it says, oh, and don't worry too much on significant figures. As long as you're getting the right answers, just go to 2 or 3 decimal places. That's fine. Okay. The second one says a sample of gas occupies 1.55 liters. Liters is a unit for volume at 27 degrees Celsius. So we have temperature. We want to quickly convert it to Kelvin. So 27 plus 273. Now we're at 300 Kelvin. And 1 atmosphere. So atmosphere, that's a unit for pressure. What will the volume be? So we're solving for volume. What will the volume be at negative 100 degrees Celsius? So that's a temperature value. So it's 273 minus 100 this time, or negative 100 plus 273 if you wanted to plug it in your calculator that way. However you figure it out, it's 173 Kelvin. Okay, and then it says that there's the same pressure. So actually we don't even have to worry about this pressure because if it's the same, it doesn't affect our calculation anyway. So in this particular example, our variables are temperature and volume. So we're going to take a look at our combined gas law, and we're only going to use the formula for temperature and volume. And you can see here, volume is divided by temperature of one set of conditions, and that will be set equal to volume divided by temperature for the second set. So V over T equals V over T. And then we can plug in the numbers. So our first volume was 1.55. We divide it by the temperature, which is 300. We set that equal to the new volume, which we are solving for. So we can put X up there this time. And then the second temperature was 173 Kelvin. And then we can solve. This time I will just do cross multiplication with you. So if we do 1.55 times 173 and then divide it by the 300. And that gives us 0.89. And the unit is liters on the original volume, so we'll keep it in liters on this one. The last example is number 3. And it says, let me switch up the colors. Number 3 says, a sample of oxygen gas occupies a volume of 250 milliliters, so that's V, at 0.88 atmospheres. Atmosphere is a unit for pressure, so that's P. What volume, so we're solving for volume here, will it occupy at 1.2 atmospheres? So in this one, we only see V's and P's. So you go up to your combined gas law, and we see that PV is equal to PV. And that's the formula that we're going to use for this one. So I'll write it down here. PV of one set of conditions is equal to the pressure times volume of your second set of conditions. And then we can plug in our numbers. So our first pressure was 0.88. Our first volume was 250 milliliters. And we're going to equal that to the second pressure, which was 1.2 atmospheres. I'm not going to put the unit in, times V. Okay. Or actually, I'll take out those. We never see it like that, so I'll take out the parentheses. It's just 1.2 V. Okay, and we're solving for V. Now, in order to solve for this, you just isolate your variable. So we want to get the V by itself, so we divide by 1.2. Whatever you do to one side, you do to the other, and then you plug it in your calculator. 0.88 times 250 divided by 1.2. and that's equal to 183.33333. We can just write 183, and the unit, since we started with milliliters, we can keep milliliters on this one. And that is a couple examples with the combined gas law. Now, some examples, it actually gives you 5 numbers, and you might be dealing with 3 variables, like PV over T equals PV over T, and you're solving for the final temperature or something like that. In that case, you just do it the same way, and you solve for the missing variable.